Hi, I'm Kyle Stieber, and this is my presentation on digital forensics, the career path that I chose for that is inside of law enforcement. And digital forensics can be in throughout many different agencies. The FBI has its agency, the CIA, and many other three-letter agencies have their own type of digital forensics, and even simple, normal law enforcement agencies and police offices have some at least some degree of digital forensics. So the main question, right, is what is digital forensics? And basically, it's a combination of information technology and law enforcement and computer science, and how they correlate with each other. Because you have law enforcement, which helps to enforce law and keep society orderly, and then you have computer science and information technology. And at the end of the day, those two degree tracks basically and professional fields are all about making computers work, understanding how they work, and integrating them in with things. I myself am an IT major. So basically, then digital forensics itself is all about digital evidence and how that can be used to help law enforcement in a case. Whether that be obtaining text messages, finding deleted files, etc. Um, it's rather interesting, and later down I'll actually talk about like some specific things that you can do and actually how difficult it actually can be to obtain certain information and the lengths that some people have to go through just to get rid of information. So the history of it, basically, it started off as computer forensics, and now more or less it's a combination of all these different things of network forensics, database forensics. It's a whole culmination into digital forensics to kind of bring it all underneath one giant umbrella to make it a little more simple and flexible in a sense. And this kind of all started around in the 1990s, 1980s. More or less it developed with computers. Because you have the creation of computers and then more or less the widespread adoption of computers, and then computers being involved in crime. So obviously, since they're involved in crime, we needed to start developing policy for them and practicing guidelines. So in the United Kingdom, from my research, I found that the first official policy was developed in 1998, the year I was born, and it's called the Good Practice Guide for Digital Evidence. And that was like more or less the first official set of rules or standards that an agency would go through when handling digital evidence. And it was made because of the need for those policies and procedures. In my one class, it was actually, I believe it was in my homicide class that I was taking this semester as well. My professor was talking about how it used to be with cell phones and everything. You could have someone in an interrogation room and you could grab their cell phone and be like, oh, let's go into your recent text messages. Let's call this buyer and then set up a fake drug deal. But nowadays you can't really do that. There's whole different standards and policies and procedures that you have to go through. Excuse me, sorry. And so why I chose digital forensics, and as I said earlier, I'm an IT major, and so for me, it relates well together. So it's able to take what I'm learning in the criminal justice field and relate it to IT, which I've worked in IT for the past almost 4 years now. I'm about to finish my degree in IT, and it's actually something that I've been interested in, and I've actually looked at doing certain positions. There was a position opening for an FBI digital, not analyst. I forget exactly what the position title was, but it was basically just it dealt with digital forensics for the FBI. I believe it was in Coral Gables, I think. I could be wrong on that though. But also, I chose it because it's like a puzzle in a certain sense, and that's why I like IT. And then the whole law enforcement aspect of it can just really culminate all of that into one, where you have a crime that was committed, you have a barrier of the technology, or there's a missing link to try to nail the person down or prove their innocence. So you can use the tools to make someone guilty or not. It's a puzzle. And yeah, so for example, one of my very first IT classes, we actually went into digital forensics, and how most people think that when you delete a file, it is gone. It's away from the computer. But in reality, it's not, because you have especially with hard disk platters. SSDs are a bit different because they deal with chemical reactions to store data, but an HDD is a hard disk. It has a bunch of platters and they spin at a certain RPM, usually up to a max of 7200, and they have a little writing needle that's constantly bouncing back and forth, and it's continually writing and reading, 0 or 1 in binary code. And you think, oh, when I delete a file, it's just gone. But in reality, what happens is that information is being told as, ignore this information, it doesn't really exist anymore, and it'll be written over. Now, like on a whiteboard, if you write something down and someone doesn't erase it fully enough, then you can actually, and they write over top of it, you can see the ghosting of the previous words on a whiteboard. And the same thing can happen with computers. So even if you delete this file and it gets overwritten, there's technology and tools where we can read down layers into the hard drive to actually retrieve that information back and see what it was. So if someone had child pornography on their computer and the police were busting down their door and trying to get in, if they just hit delete and everything, they'd be like, wipe my hands, I'm good. You hand it off to someone who's a professional, in that career of digital forensics, and it'll take, depending obviously on the encryption, if the hard drive is encrypted, it wouldn't take them all that long to actually find the hidden data underneath. And there's actually procedures, like the only sure way to actually destroy any information on a hard drive is to physically punch a hole in it so it becomes absolutely unreadable, that it can't be read by any type of technology. You have to physically destroy the device. But if you don't want to destroy the device, you have to do this thing called zeroing out, and that's basically you write over the entire hard drive with just zeros, and you have to do that. It's minimum of about 8 times. There are certain technologies, and obviously they're not going to release the technologies and how far they can read down, but it has been seen that they've been able to go down like 10, 11 levels. It all depends on, and obviously as time goes on, that technology will get better, and we might even be able to read further and further and further down. But excuse me, it's insane because the process to write a hard drive like that takes forever. But think places like hospitals, if they have information records on a hard drive, they have to zero the hard drive out at least 8 times, minimum of 8 times, so that way someone can't just go in and read a patient record when they go to resale and things like that. And they have actually a whole, usually a dedicated person to just cleansing hard drives. It's a whole thing called sanitization. And in the department I work at FIU right now, there's a whole department just based for sanitization of technology. And they go in, and before any piece of technology at all in the entire campus can get thrown away, it has to be cleared through sanitization first to make sure any and all relevant information. Sorry, my headset I think just turned off. But any relevant information needs to be made sure that it is non-readable by anyone that would obtain that drive in the future. So that's what you do with zeroing out. And that's why I chose it, because it's just like, it's cool. I find it a lot of passion, and because I'm not a criminal justice major, but I'm an IT major, and this is something that kind of brings both of the worlds together. It gives me something easier to talk about and everything. I hope everyone stays safe at this time. And these are my citations. Thank you.